So oblique asymptotes occur when our function is, I'm going to say, top heavy, meaning like this function, we have the higher power on top, all right? It's top heavy. We have that higher degree on the top. And what happens when we have that higher power on top is we can actually simplify this function. It's not in lowest terms. So we're going to write the equation of the oblique asymptote, and that turns out to be easy to do. And I'm telling you to write it in this form. This is not the instruction in your book, but this is Q of x represents the quotient in terms of x, and R is for remainder over divisor. So we'll talk about that in just a second. Q, yeah. So to go back to numbers, I'm going to say this is like having the fraction 23 divided by 7. Do you see how it's top heavy? Okay. So because it's top heavy, heavier on top, what that means is we could actually do some division. And you could say, oh, well, how many times does 7 go into like 23-ish? You'd do 3, right? And then you'd multiply and get 21. And then you would subtract and get 2. And what's 2? The remainder. So we would say 2 sevenths, or quotient plus the remainder over the divisor. Okay, so 3 and 2 sevenths. We're going to do the exact same thing. Because our rational function is top heavy, just like this, we're going to do some division. You guys get to do synthetic division. So what are we using to divide by?
Yes.
1. What goes across the top?
0.
0, negative. Got to fill in the missing terms. Very good, very good. It's been a while, I know. And then what's on the outside here? What do we use? 2. Yes. Nope. Change his mind. So we always use the, I like to say 0. What x equals. X would equal 2. All right. This goes, bring down the 1, and we multiply. 1 times 2 is? 2. And 2 plus 0 is? 2 times 2 is? 4. And then we get?
3.
Just 3. Good. Okay. So what was 3? What's 3? Remainder. Remember that? All right. So what's 1 and 2? It's the quotient. Very good. Yeah. And if you convert that back into a polynomial, then it would represent 1x plus 2. And if I want to write this in this form, f of x equals quotient, q of x, plus remainder over divisor. The remainder was 3, and the divisor, the thing that we divided by, was x minus 2. So what we've done is we've actually converted this into lowest terms. This thing out in front represents that oblique asymptote. Y equals x plus 2 is that oblique or slant asymptote. I want to show you what that looks like. So if I were to graph this, x squared minus 1 divided by x minus 2. Notice all the sets of parentheses there. Lots of parentheses. And watch this. Craziness, yeah? Here, let me change my window just a little bit. I'll go higher up on the y-axis so you can see a little bit more. So you see, it doesn't have a horizontal asymptote. It has an asymptote going right in between here. And it's the line y equals x plus 2. So I'm typing that in, and you can see it's going to thread itself right between there. That's what that horizontal or slant asymptote does. It doesn't tell us what happens close to 0. Crazy things happen close to 0. But it does tell us what happens for x values that are very large. I'm going way out to 100 by 100 window. So, and you can see, look, doesn't it almost looks exactly like the line y equals x plus 2 far away. Okay, so that's what a horizontal or an oblique asymptote does. It doesn't tell us what happens close to 0. It tells us what happens for large values of x. Okay, it approximates. It gets super duper close to this line. Okay, but close in, we see it does some interesting stuff. All right, so you can find an oblique asymptote just by doing some division. Really easy to do that. It's just the quotient, whatever that quotient turns out to be. What if it's not top heavy? Then we do the divide through by the highest power of x. Yeah, so we're going to try some. A couple more. Example 2, graph and label. A is really interesting. Again, you guys get to use your calculators. So I teach this now where we don't spend a ton of time because you have the calculator to help you graph it. But we will find our asymptotes. Those are the most important things here. So for this first one, we have 3x over x squared plus 9. Is it top heavy?
No.
No, it's not. So before I do anything, I want to talk about domain. Where does domain come from? The denominator right here. And can I factor that? No. So it doesn't double bubble. It's not subtraction. It's not difference of squares. Right. So instead, I know that denominators are not allowed to equal 0. So this is a sort of equation I could solve. And that's going to help me figure out the domain. If I solve, I'm going to move the 9 over. What happens? I becomes imaginary.
Right.
All right. It's imaginary, which means, is there anything that I can exclude? There's nothing that I get to exclude. So there's no x's to remove, which means all the real numbers work just fine. There's no vertical asymptote in this case. This is a very interesting graph. Now, if I want to find my horizontal asymptote, the horizontal asymptote I can get by dividing through by the highest power of x. So I'm going to take my function and divide, what's the highest power of x? X squared. So I'm going to divide every single term through by x squared. So x squared divided by x squared, and then 9 divided by x squared. And I'm going to clean it up a little bit. This seems familiar. This cleans up. How does 3x over x squared clean up? 3 over x. X squared divided by x squared? 1. Does 9 divided by x squared clean up? No. And so we want to know what happens as x gets really, really large. As x gets really, really large, what happens to 3 over x? It gets really, really, really small. Very good. 3 divided by a billion is infinitely, it's so small. Super, almost 0. Okay? And we got a 1. And then again, 9 divided by something super duper huge. What happens to 9 divided by something super huge? It becomes infinitely small, almost 0. Super close to 0. And so what does this clean up to be? 0. So that's our asymptote, y equals 0. Okay. And the same would be true for x being infinitely small. If it was like negative infinity, it'd be like subtracting 0. So it doesn't matter. Sometimes there's something left over, and sometimes it just happens to be 0. Boy, that takes up space, doesn't it? All right. So if I were to make a graph of this, the only thing I know is the horizontal asymptote is y equals 0. There is no vertical asymptote. And so I would basically want to do a little XY chart for some values of x, like -2, -1, 1 and 2, even 0. Or I could just use my calculator because that's the easy thing to do. So I'm using my calculator.
Oh, wow,
Whoops. It's weird, right? 3x divided by x squared plus 9. Is it? Is it a little bump?
2 little bumps, yeah.
Yeah. Oh, look at that. Really tiny. So what's happening is I don't need all of this above 1 or below 1. I'm going to change my window and change my y minimum. I'm going to say -1.5 to +1.5. And so you can see, there it is. That's what it looks like. Okay, kind of interesting. But we can plug in some values. I can use trace and type in -2 and I get like -0.4. But that's what your calculator is really good for. For -1, I get -0.3. For +1, I get 0.3. And for 2, I get 0.46. And again, you could plug those in manually. You could just take that -2 and plug it in and work it out. But why bother? So I'm just going to sketch this little graph. And then, I don't know, label a point here. I get at 1.3, and at -1, I get -0.3. Okay. So we want to find the asymptotes, and then we can find some ordered pairs using our calculator. Okay. All right. Letter B. What's the domain of letter B? Cannot be -1. Denominator domain. Denominator domain. All right. If I know that x cannot be -1, then that makes up my asymptote that I'm going to graph. X equals -1. And I can graph that. At -1, I have a vertical asymptote. The dotted line is not really there. It's just helping me draw my graph. So what do we need to do for the other asymptote? What case is this? Synthetic division. This one is top heavy. And since it's top heavy, we can do some synthetic division. So what should I use on the outside here? -1, good. And what goes along the top?
103.
103, good. So I'm going to bring down the 1 and multiply. 1 times -1 is add, we get multiply. 4 is the remainder. Here is our quotient, and that's where our I get oblique asymptote. I'm gonna use slant asymptote just because I don't know. O is weird. O for OA. If you wanted to write OA, that would be fine. So convert that quotient back to a polynomial. What is that? X minus 1. So that is our oblique asymptote. And that's a line we know how to graph. So that goes through -1 on the y-axis. And what's the slope? 1/1. Up 1/1. Up 1/1. So that gives me this little oblique line or slanted line. Okay. And now I just have to figure out what goes in these wedges. And I can do that a couple of ways. I can make a little table of values. I would want to choose numbers to the left and to the right of my vertical asymptote. So what are some values to the left? -2, -3. What else? What's to the right? 0 and 1 would be good choices for x. And again, you could just plug those in, or you can just use your calculator, which is what I'm going to do. X squared plus 3 over x plus 1. Watch those parentheses. Oh, sorry, I'm going to do a zoom standard so that my window resets. You can see we've got that slanted asymptote in there. See how the graph sort of approaches, gets close to that slanted line. And I could use trace. When I plug in -2, I get -7. -3 is -6. 0, I get a 3, and 1, I get a 2. Oh, those are nice numbers. Yeah, crazy. -2, -7. Might label that one. You can see we get this weird shape. I can change my window. You can see what that looks like a little better. You see how it's sort of like a smush doll. And then 0, 3 is another value. Your book talks about all kinds of things that you can do that maybe 30 years ago were important. They talk about finding symmetry and finding all the intercepts. It's called SIRETS is the abbreviation. Symmetry, intercepts. I don't know what the R stands for. It's incredibly involved. And since we have graphing calculators, I just don't think it's necessary to spend so much time doing that. So this is it. Finding those asymptotes is really what you want to be able to do, ladies and gentlemen. And then, it's an XY chart anytime you need to graph. Okay? Do you have questions for me? Okay?
No, but I will.
Yeah, you will. That's fine. Ladies and gentlemen, you should know that this is it for this chapter. And in fact, that's it for this year. I'm done teaching for the year in this class. I was going to do another chapter, but then I was like, let's not.
Thank you. Thank you.
So we got a few days. You guys will be reviewing Thursday and Friday for a chapter 4 test. Chapter 4 test will be Monday.
And you guys next semester will get out an hour early.
No, I said this year. I'm teaching for this year. Oh yeah. So then we will have 2 pretty easy worksheets for just a couple of days, and I will also give you a review that you can start working on. The official days to review for the final will be Thursday, Friday, and Monday and Tuesday, and you guys have your final on Thursday. Yeah, and that's it. That's the semester. It's a wrap.
I have my AP chemistry final, then I have this final right after.
Oh, that'll be fun. All right. Very good, ladies and gentlemen. You can get to work.